Hello and welcome back. I'm Colin, and today we are going to be doing a bit of service provisioning in our Apstra lab. In the last video, we built out our host systems. We used VSRX for LACP at layer 2 because I hate doing LACP on Linux in a virtual environment. And we set up some Ubuntu Mate hosts. There's obviously a lot of flexibility for how you can do this in your own environment, since it's not really Apstra stuff. It's just the tooling that we'll use to verify the fabric's working. Watch that video if you need any guidance. Where we're picking up today is building our routing zones, which are the analog for routing instances in Junos, or VRFs if you're using Cisco, or Arista, as they copy Cisco. Virtual networks, which is our vxlan VNIs and subnets, and doing some connectivity templates, which is how we are going to associate the VNIs, the virtual networks, with our host connections. We are going to get started with a touch of housekeeping. Here's our environment. Again, this is what we did in the last video. That housekeeping is host names and node cable maps. And actually, we don't need to do, I said update SRX config. Ignore that. I should have taken that node out. Nothing to update. We're good. First things first, if we go to staged and look at the names of our nodes, server rack DC1, these are all system generated. They're not very intuitive. I want to change these to match these names down here. We'll start with the single homed host, as this one over here only has the one link. And that's easy to figure out by just clicking show links and expand nodes. And in this case, we can see it's the sys003. So we'll click on that and we'll change the name. We have to change the name in two places. There's the host name, and there's also the system name under properties. And this system name is what updates this bit here, which is arguably more important because that's going to make it a lot easier to identify where this system is within the Apstra configuration. All right, so that one's done. Click that, we'll do the next one. Because we're also going to be doing the cable maps, it doesn't matter which of these auto-generated names maps to which of these two hosts, because I'm just going to name them and then I'm going to set the physical links where they need to be for that specific host. So in this case, we'll just call this DC1-BMS-2. And we'll do the host name as well, DC1-BMS-2. Did you not take that? Maybe I missed the save button there. DC-BMS. Hey, -2. Save. Thank you. Good. All right, close that, and then do 3. DC1-BMS-3. Save. No? Come on. Come on. Better. DC1-BMS-3. Save. Great. Oh, I hear footsteps. I'm probably going to have to pause here soon and go say hi to my son. Maybe make him some breakfast. But we're in it. So if I do that, I'm coming right back to this. I don't think I have any calls this morning till 9:30, and it is only 8:22, according to the clock. All right, so our names are updated. Let's go update our cable maps. We go to links right here, and then we click this button right here. Originally, these links were just any old interface that didn't conflict with interfaces we needed in the fabric, but now it matters. And you can also see why changing these names first is super helpful. We look at our topology, we see that XC009 is assigned to BMS1, and XC10 to BMS2, and XC11 to BMS2 on both of these leaves. So starting with BMS1, which is single homed, we change that to a 9. 2 is a 10. And 3 is 11. Update. Good to go. So now our cable map looks right, and we can start building our routing zones. Go to virtual, click on routing zones, And since we're only building a single tenant for this exercise at this point, we'll probably do multi-tenancy later. Oop, all right, kind of overran the buffer on the browser there. We're just going to name this one tenant1, tenant-1. We'll give it a VLAN ID that's unique. This will not be used or assigned to any of the VNIs. So this is just a unique VLAN ID for this specific tenant, just for peering. And the VNI that I'm going to basically take 10,000 and add the VLAN to it. And I'll use this for the VNIs as well. So this would be 10,010. Done. Create. Finished. Jump over to virtual networks. We're going to create two because VN101 and VN102 are in this data center, and VN101 and 103 are in the other data center. So we'll call this VN101. Routing zone is the one we just created. You can let this information be defined by a resource pool, but then it doesn't have an intuitive mapping. Now, if this name is just like the name of a service, then you might allow it to be automatically assigned. I think most folks are probably going to go in here and manually assign this. I don't know. I like to know exactly what is being configured often. So that level of abstraction is a bit too far for me in this case. But do as you will. As long as you know what's going where, the fabric will take care of the rest. Essentially, it's just pump packets in one end, pump them out the other. Now, you do want to make sure you click this Create Connectivity Templates. You don't have to. You can create them yourselves, but this will save you a step. Because this is VN101, we have an untagged host, and then this host is tagged. So I'm going to create a connectivity template for both. And you'll see what those are in a minute, and then we'll create connectivity templates when we do the DCI video. So you'll get a good run through on that. Click Create Another because we're going to do VN102 as well. One, 102. Oh, ha! I don't see my options because I need to scroll up and check vxlan. All right. 102. 168.102.0/24. 102.1. And we only need a tagged for this because this is an AE interface with a trunk interface and just a single VLAN. We could have done access as well. I think most folks are going to be doing trunking though. These connections are going to go into a host that's got multiple VLANs. Maybe it's a hypervisor. I don't know. We're doing it both ways here. Check that box so that it assigns the virtual network to that leaf pair. If you have a data center with tons of racks and tons of leaf pairs, you would check this box next to any leaf pair that required access to VN102 in this case. It might be all of them, but this is where we can be pretty prescriptive about where our virtual networks are actually going. Essentially, if you don't assign interfaces on a leaf pair to a virtual network, you don't need to run the virtual network on that box. All right, so that's create. And since we checked those boxes for the connectivity templates, up here, we're going to see those default connectivity templates. Now, you'll see this red splat here. That is because I forgot to add loopbacks. So let's go back here. And since we're in DC1, we'll add our DC1 loopback right there. Click Save, and that will clear. Apstra is really good about telling you when you've forgotten things or giving you a yellow mark when it's like, you sure this is right? Everything's green. That means we could commit right now, but we're not quite done. We'll go over here to the connectivity templates, and this is where we assign these VLANs, these VNs to specific links. Now, coming back here to physical, if we go to links and nodes, actually, let's just click this because the question might come up as let me actually go back to connectivity templates. When we click this link button here, you're going to have some options. This is another reason why we changed these names. If you didn't change these names, you can always go back to, or if you're not sure what's plugged in where, you can always come back to physical and click on one of these servers. Actually, I think it's under topology. And if you click on one of these and then edit links and update logical links, you'll see the aggregate number right here. That'll tell you what that AE interface is. In our case, since we changed the names of the systems, it becomes a lot easier. So we know this untagged goes to BMS1, so we'll click the link button here to assign. And look at that, BMS1 on interface 9. Great. Click, apply, assign, done. Now the tagged goes to BMS3, done. and the tag for EN2 goes to BMS2. Sign and done. Cool. Let's do the same. I'm going to go ahead and commit this and jump over to DC2, and we'll do the same. Let's give these an intuitive name. Again, since I'm going to be, it doesn't matter what's what right now, because I'm going to be doing the cable map in a minute, so I can tell it what to plug into. So this is DC2-BMS-1. Save, properties, DC2-BMS-1. Save. Might be doing this a bit too fast. DC2-BMS-1. There's like a little bit of a burn-in time when you save things. If I had more CPU or memory assigned to this Apstra server, it'd probably be a lot faster. But you know, I have a finite amount of resources on my hypervisor. It is a trooper, though. DC2-BMS2. Save. Wait. Just waiting. All right, let's try it now. DC2-BMS-2. Save? Huh? Yeah. Seem to think like you did. Give you a minute? No? Too fast again. All right. DC2-BMS2. Oh. Let me guess. Yes, you did it. I just had to wait longer. I was being impatient. All right. Those are changed. Let's do our links. Edit map. It should be 10 and 11 like the last one. 10 and 11. Perfect. BMS1. 10. And 11. Update. So now everything's plugged in where it's supposed to be. Virtual. Create our routing zone. Call this tenant 1, just like the other data center. VLAN ID is the same. ID is the same. Create. Pretty straightforward. We will wait to assign our loopback. Come on, you. Where are ya? Tenant 1. There we are. You. DC2 loopback. And build our virtual networks. VN101, 1001, 1, subnet 192.168.101.0/24, 192.168.101.1. We're only doing tagged in this data center. There's no single home host. And assign it to the appropriate server leaf. Create a different one, click create, scroll up, vxlan, EN103, tenant 1, 103, yes, 103, 168.103.0/24, 168.103.1. Again, only tagged, and create that. So now we've got our virtual networks. We've done our host names. We've got maps, just the connectivity templates at this point, and we should see, great, those two. BMS1, this is VLAN 101, so that goes to BMS1, DC2, BMS1, and then 3 goes to 2. So you get assigned there, and you get assigned there. Cool. Committed and commit. Yes. Let's check on DC1. Okay. Everything committed. I don't see any alarms. Let's get into topology and let's take a look at DC1 leaf 1 and look at the configuration of that box. So there we go. So we'll do show configuration interfaces XE009. And here, it deploys, Apstra deploys everything as a trunk, but in this case you can see there's a native VLAN ID assigned as well. This means that if you do switch over to a tagged interface and you want to stack members, it's non-disruptive. It just keeps this native VLAN ID or removes it if you pull it, but we don't have to change the interface mode, which is important. This looks right? We've got a native VLAN ID 101. It'll be sending untagged frames to that single homed host. Now let's look at AE0. Let's see, AE0. Oh wait, is it AE1? Right. AE1 and AE2. It doesn't zero index the aggregates. In this case, it's carrying a trunk. And if we go look at our configuration of this device, it's a trunk member 102 and a trunk member 102. Terrific. So let's do show LACP interface. And our LACP is up. That is great. Looks good. You don't have to do any of these steps. I'm just showing you what Apstra does when you commit. Let's assume that just BMS3 works. So click on this, bring it up, and see if we can ping it. And if we can't, we'll figure out why. We'll start by pinging the default gateway. In this case, I'll just ping myself, 190. Let's do this. Oh, IPA. There we go. All right, so we do have the right IP address here. Ping 192.168.101.1. Can we ping our gateway? No, not yet. That's interesting. I might have some configuration problems here. Down here. Let's see what's going on with that. Because that gateway should be configured on that box. Alright, get back to the leaf. Oh, I'm on the leaf, good. Show interfaces terse. There it is, IRB 101. Cool. We're not gonna do that. Let's check our bridge. Show configuration interfaces. Numbers 102. Oh, it's untagged. Is that my problem here? Oh, I'm on the wrong bridge. Sorry. I'm like, why? I'm not seeing what I expect to see. Let's look here. Show interfaces. Oh, well, geez. This is not right. GE, so 101 is configured as a trunk. It is not a trunk. So it turns out that this is configured as a trunk right now, and I thought I'd configured that as an access interface. So I can change this in Apstra by making an access interface, or I can change it here. I guess that note that I had up here about updating the SRX wasn't wrong. This is easy enough. Edit interfaces. Actually, I don't even need to do that. Set interfaces G001. .0 family Ethernet interface mode access. I'm here already. Commit and quit. There it is. Funny. All right. I can ping my own IP. That's good. And let's see if I can ping that other host. I can. Lovely. Now, .22. Can I ping the other VN? Yes. All right, so without too much fuss and one configuration issue, these devices can all ping each other. Great. Now we'll test this, and assuming it all works, we're done. All right. Obviously, we can't ping between the sites yet. That'll be the next video. Oh, I think I just mistyped that. Great. Ping 192.168.101.1. This would be me pinging the gateway here. So that works. And let's see if I can get to 103.55. And I can. So we also have full reachability between these hosts as well. And that, my friends, is it. This was a fun one. I like this one. The next video is even more fun though, because it's DCI. We get to build our BGP between the sites. I'll show you how to do an external connection to the internet if you want to play that game. Overall, we're getting into the parts of Apstra that are really fun. When we do demos, I tend not to spend a lot of time on the build because you do the build once. I really like the operational stuff. I mean, that's really that's the part you have to live with. And Apstra is just terrific. So we're starting to get into it. We're starting to taste that. So it's really exciting. Thanks for watching through. Hope this was useful, and I also hope to see you in the next one. Take care and have a great day.